Hi everybody, we're about ready to do our second video that's on factoring. We recently did a video that was on taking out the greatest common factor, and now we're going to learn a second technique. Before I actually cover the factoring, I want to do some multiplication, because remember that factoring is reversing multiplication, and sometimes the more you understand what happens with multiplication, the more likely you're able to understand how to go about the reversal or the factoring. So here I have some problems that we did, say, 2 sections ago where we were practicing foiling or multiplying. So I'm going to multiply the x by the x and the x by the 2, x squared plus 2x, and then it's a negative 3's turn, negative 3x. Negative 3 times 2 is negative 6. So I initially get 4 terms. And then when it comes time to combine the 2 like terms in the middle, I'll go ahead and write x squared. He has nobody to combine with. The 2x minus 3x is negative 1x. I usually write just negative x because there's an implied 1 there. And then minus 6. Notice when we multiply 2 terms by 2 terms, we get 4 terms initially, and then usually we end up with 3 terms. Let's see if that pattern holds true here. I'm going to multiply the x by the x times a positive 3. The 7's turn now, plus 7x plus 21. And now it's time to combine the 2 like terms. X squared plus and 3x and 7x is 10x, and then plus 21. Again, 2 terms by 2 terms ended up, when we multiplied them, ended up giving us 3 terms, just like in the previous problem. This one over here that I've listed, and you probably realized this back when you were doing some multiplying out yourself. We multiply the x by the x, and then we get a negative 4x. And now it's the 4's turn, so plus 4x. And then positive times negative is negative 16. Notice what happens to the 2 middle terms in this case. You have a loss of 4 and a gain of 4. When you take a negative 4 and you add it to a positive 4, you get 0. And 0 times x is just 0. And we don't tend to write terms that are 0 because they essentially cancel out. So this term remains. These 2 cancel out with each other. And then the minus 16. So here we have our first case where multiplying 2 terms times 2 terms gives us only 2 terms. Now why did that happen, you might ask? Well, think about it. These 2 canceled out in this case. That's why there's no x term here. In the other cases, they didn't cancel out. That's why there was a 3rd term in those results. But what made them cancel out was the fact that these 2 things look alike, except for the sign between them. The fact that these look alike, the x and the 4, the x and the 4, means we get the same size because the outers is a 4x and the inners are a 4x. But because of differing signs, they end up canceling each other out because they're opposite in sign. So that's why we ended up with only 2 terms. Let's see if we can use this idea to our advantage when it comes to working backwards. Because remember, factoring is taking something like this and figuring out what I must have started with before somebody multiplied out. All right, so let's take a look at that. So I'm going to grab there's my eraser. I'm going to get rid of this. One of these days I'll mount these boards on a wall so I don't have to hold them up while I erase. Okay, so now let's take the result and see if we can work backwards. So if I gave you something like x squared, so this is called, first of all, I should probably tell you, this is called factoring a difference of two squares. So that would be the kind of the title of what this is all about. And do you see difference of two squares? Each one of those words is important to what we're looking for here. If I gave you x squared minus 25, this is one of those two-term things that perhaps when it factors into two sets of parentheses. Most of the time, 2 terms times 2 terms gives us 3 terms in the end. But we just notice that certain structures of the problem lead to having the middle term drop out. So basically, to factor this, you want to put what times itself gives you x squared. X times x is x squared. And what times itself is 25. And if I were foiling this out, I would have to have opposite signs. It doesn't matter if you go plus minus or minus plus, it doesn't matter. But the fact that I put one of each sign here means that when I FOIL it out, I'll get a negative 5x and a positive 5x, and that's going to cancel out, which is why it'll only have 2 terms when I'm done. So let's kind of tie this idea to this title I put up here. A difference in mathematics means subtraction is happening. There it is. 2, of course, means 2 of something. And squares are things that when you can multiply something by itself and get that number or quantity, those are considered squares. So I knew that 5 times itself gives me this, and x times itself gives me this. So that's a perfect square, that's a perfect square, and that's a different sign. So it's a difference of 2, see there's only 2 terms, squares. They're both perfect squares. So basically, when we see something that's in this form, with a different sign, a perfect square and a perfect square, we can factor it in this way. Putting here and here what multiplies by itself to give you there. Here and here, whatever we multiply by itself to get 25. And then one of each sign. Again, whether you put the minus here and the plus there, vice versa, doesn't matter. So we had a difference of 2 squares, and this is how this is considered factored right here, because remember we talked about something being factored if it's written as multiplication, and here we have this stuff times this stuff because the 2 parentheses are bumping up against each other. Well, that's all fine and dandy. Last night's homework, you took out a greatest common factor. Do you see x's in both terms here? No. Do you see a number that goes into 1 and 25 evenly, other than 1 itself? No. So this is not a problem you could have factored using yesterday's technique, which is why we needed a new technique in general. Let's try another couple of these. Okay. Okay, so if I gave you 4x squared minus 36. No, I'm going to make that be something, because that's coming up soon. I'll give it a 49. How's that? So, you know, the types of factoring that we learn, we're going to accumulate more than one method. And later on, we're going to get problems out of the blue, and we're going to have to decide what method is appropriate. So yesterday, we learned how to take out a greatest common factor. It's a good idea to always look at something like this and make sure it doesn't have a common factor. Because in reality, when we have to factor like this, we're not gonna be told which method of factoring eventually to use. So, is there something that goes into 4 and 49 evenly? No, there is not. Are there x's in both terms? No, there are not. So basically, there is no greatest common factor, which is why we won't use yesterday's technique to do it. Okay, so now I see I've learned this new idea of factoring a difference of two squares. I should first see if it's a difference of two squares. Is that a different sign? Yes, it is. Check. Is that a perfect square? Can you think of some quantity times itself that gives you this? Well, I think a 2 and an x. 2x times 2x is going to be 4x squared. So that is a perfect square. Can you think of something times itself that gives you 49? I think we get a winner, 7 times 7. So, to factor this pattern, I set up two sets of parentheses, each designed to hold two terms. I put here and here what multiplies by itself to give me this. So it's going to be the 2x and the 2x. And then I put here and here what multiplies by itself to give me 49. So it's 7 and 7, and then put one of each sign. Okay, so is this written as multiplication? Yes. This is multiplying this, because the two parentheses are bumping right up against each other. So this is now factored. Let me give you a couple more. I'll give you one to try on your own right now while I'm busy erasing the other side of the board. Try something like 16x squared minus 1. So go through your pre-flight checklist, see if that meets this description, and see if you can factor it as a difference of two squares. How you doing? Do you think it meets the pattern of a difference of two squares? Well, let's see. Is that a different sign? Yep. Is that a perfect square? Can you think of something that times itself that gives you that? Yep. 4x times 4x. And is 1 a perfect square? That's kind of a strange number, but can you think of something times itself that gives you 1? Maybe 1 times 1? So if that's the case, that's a perfect square. So we set up our two sets of parentheses, and we said this was what times itself? 4x and 4x. And then what times itself gives you 1? Well, 1 times 1 does. And then put one of each sign. Again, it doesn't matter whether you write the minus sign first or the plus sign first. Just make sure you have both. If you don't have both signs being different from each other, then that middle term all of a sudden won't cancel out. See, this is something that's hugely important. This is not an equation. I'm not allowed to multiply both sides of this because there aren't even any sides. There's no equal sign. So with expressions, which is what this is, you're not allowed to change its value. So this has to multiply back to this, or else you didn't factor it right. And that's true actually for any kind of factoring, even the greatest common factor method that we used the other day. If what you ended up with doesn't multiply back to the original, then in fact it's not, you didn't factor it correctly, or maybe it wasn't even factorable. So this is your final answer. It's stuff times stuff. So when you factor, you're basically writing something as multiplication, or as they say, a product. So this is a product of this times this. And basically, if somebody took this and multiplied it out, they should get something equivalent to that. So if you're a good multiplier, you have a built-in way of seeing if your answer is coming out right. So some people, they automatically multiply this out again to make sure it matches that. That's a great way to check, but just remember to box this up as your final answer, because when I say factor, I'm fully expecting that you know it's the product, not the check that you do, perhaps a little bit later. Let's try another one. I'll erase that in a second, but let's try x squared plus 9. And again, if you want to get in the good habit of kind of always seeing if other methods work, you can say, are there any greatest common factors? There are not x's in both terms, and nothing goes into a 1 and a 9 evenly other than 1 itself, and we don't factor out a 1. Okay, so now let's see if this meets a difference of 2 squares. Is that a different sign? Difference means subtraction, remember. That is not a difference of 2 squares. So this cannot be factored according to this method, because it isn't even a difference. So this, we would say it does not factor. If you had gone about trying to factor it and you had written x plus 3, x plus 3, you see how these signs are not different from one another? Well, if I FOILed it out, I get x squared plus 3x plus another 3x plus 9. That middle term wouldn't cancel out. It would actually give you x squared plus 6x plus 9, and that is not the same as what I was given. So that would not be a right factorization. Well, you might have thought, well, how about if I did x plus 3, x minus 3. In other words, I'll pretend that that's a minus sign. And now I multiply this out. X times x is x squared. Plus 3x and minus 3x cancels out. And then positive 3 times negative 3 is this. And do you see how that doesn't match this? So that's why you have not correctly factored it if you wrote it like this. So really, that has to be a different sign, a subtraction sign, than that, and that have to be perfect squares. I'm going to give you a moment to take a screenshot of this if you want, but in general, you can always take a screenshot of any screen that I show prior to me erasing it, so that you have that to add to your notes if you want. Okay? It's a good idea to always take notes when you're watching a video. A 5-minute video should take you about 10 minutes to process if you are pausing it enough to write down notes. So that would be always that way you can have your notes right there handy, and you won't have to always go back and rewatch the video. Rewatching the video is something that's better to do as you're coming up to a chapter test to kind of refresh your memory and see if you remember this stuff. Okay, so finally here's a couple more. How about something like, let's say 9x squared y squared minus let's say 100 w squared. There we go. Always a good idea to see if, because usually you'll get this in isolation, it's probably a good idea to see if this right here might have a greatest common factor. But nothing goes into 9 evenly that also goes into 100. There are not x's in every term. There are not y's in every term. And there are not w's common to every term. So we don't have a common factor. So now I see maybe it's a difference of 2 squares. So I see a different sign, check. And I got to see if these are both perfect squares. So basically, Can you think of something times itself that gives you that? Think 3xy, Mike. 3xy times 3xy gives me 9x squared y squared. So, and is that a perfect square? I think a 10w times a 10w would give me that. So I write two sets of parentheses. 3xy times itself. 10w, 10w, and then a plus sign and a minus sign. Again, the order not mattering. This is going to multiply back to this, believe it or not. So this is the factorization, where we have successfully factored this because it's written as stuff times stuff. Okay, so that basically gives us a quick look into a new form of factoring, and you're going to use that form on your homework. So I hope this was helpful to you. Have a good night.